Hello everyone, welcome back to my channel. In this video, I will explain in detail what stack is and how operations are performed on stack. This will be like a foundation video before writing programs for stack operations. So let's start the video. Stack is a linear data structure that follows the principle of LIFO, which is short for last in first out. LIFO means that the last element inserted inside the stack will be the first to be removed. You can think of stack data structure as a pile of plates as shown here on top of one another. You can either put a new plate on the top or remove the top plate. If you want to pick the plate at the bottom, you must first remove all the plates on the top. This is exactly how stack data structure also works. Let us understand this in detail with few examples. Consider this as a stack data structure. As you can see, there is one open end and one closed end. You can perform insertion and deletion operation only from the open end. We cannot perform any of the operations from the closed end. Say I have some data elements. Now I will try to insert one of the element into the stack. As I said, I can only perform insertion and deletion operation from the open end. So I will insert this element from the open end into the stack. The element will take up the very first position. This operation is called push, that is inserting into the stack. Let's take one more element. Now I am pushing this into the stack. It will take the next empty position. One more. I am pushing this element into the stack, and basically all these operations are called pushing. Now I will remove the top element from the stack. This operation is called pop, which is removing elements from the stack. Keep in mind that we cannot remove elements directly from anywhere in the stack. Remember the analogy of plates. I can only remove the plates from the top. I cannot take the plates that are in between. Similarly, even the stack works in the same way. I can only remove the top element from the stack. Similar to this, while insertion as well, I cannot insert an element into the last position by keeping these two empty. The previous positions has to be filled in order for us to insert any element into the stack. So I can only insert into this position. Similarly, we can understand what LIFO order means. The last element to be inserted into the stack will be the first to be removed from the stack. The last element that is pushed into the stack will be the first to be popped out of the stack. And that is what LIFO order means. Now let me insert few more elements into the stack. Now what if I have to insert one more element into the stack? Our example stack can hold maximum of 5 elements at a time. Now if I try to insert one more element into the stack, I won't be able to do that. And this condition is called overflowing. Similarly, we have one more case called underflow. I am popping all these elements out of the stack. Now if I perform any more pop operations, I won't be able to retrieve any other elements from the stack. And this condition is called underflow. So overflow and underflow. Overflow is when your stack is completely full, and underflow is when your stack is completely empty. This is the overall functioning of the stack. Now there are certain things that we need to understand in order for us to write program for all the stack operations. Every stack has a maximum size. This decides the maximum number of elements that can be inserted into the stack. In our example stack, we have taken the maximum size as 5. So at a maximum, we can only insert 5 elements into this stack. Internally, stack is stored just as an array. So that is the reason why the indexing starts from 0. There are few more things that we need to understand in order for us to write program for stack operations. We will be using a variable called maximum size or the max size. This variable decides the maximum number of elements that can be stored inside of the stack. In the example over here, I have taken the max size as 5. So at a maximum, I can only insert 5 elements into this example stack. We will make use of one more variable called top. This is one of the important topic in stack. since we will make use of this variable to perform all the operations on stack. You will understand this while writing program. We will make use of this variable to write all the operations on stack. So that is the reason why this is a very important topic that you need to have a good understanding of. So top is a variable that we will be using to point at the topmost element in the stack. Say for example, I will insert 2 elements into the stack. Now the topmost element here is 8. So our top variable will be pointing to that location. It just means that the top variable will be holding the value of the index 1. So at this point, top variable will have a value of 1. Now if I insert one more element, this will become the topmost element in the stack. So I will have to increment the top variable to this value. So now top variable will be holding the value of 2. Initially top will be pointing to -1. This just means that the stack is completely empty. And as we insert elements into the stack, the top variable will keep incrementing until it reaches the maximum value. At this point, we can say that the stack is completely full. Since the top variable is pointing at the maximum index, that means there is no other empty space left in our stack. So we can easily conclude that our stack is full. So to recap, initially top will be pointing to -1. When top is pointing to -1, it means that the stack is completely empty. And when the stack is completely full, top will be pointing to the maximum index that is present in the stack. In our example, that is 4. So when top is pointing to the index 4, we can conclude that our stack is full. So at any point of time, we can get the status of the stack with the help of top variable. Based on the value that is stored in the top variable, we can identify whether the stack is empty or whether the stack is full, or if there is any empty space left in the stack for us to insert new elements. And that is how we will be using the top variable. Please make a note of this. Now let us understand how push and pop operations work with the help of top variable. Let us first understand how push operation works by writing an algorithm for it. As I said earlier, initially when the stack is completely empty, top variable will be pointing to -1 index. The push method takes 3 arguments. One is the current value of the top, maximum size of the stack, and then the new element that we are going to insert into the stack. The push method will take 3 arguments. One is the current top value, and then the maximum size of the stack, and the new element that we will be inserting into the stack. Let us say we are inserting this element into the stack. The first thing that we need to do is increment the top value. It's like finding the next empty space in the stack. And into that particular location, we will be inserting our new element into the stack. This is basically how push operations work with the help of top variable. Now, if I have to insert one more element into the stack, the first thing that I need to do is increment the top value. I have found the next empty space in the stack, and then I will insert the element into that index. Similarly, for the rest of the elements, we can follow the same procedure. Increment the top value and insert the element into that index. I am incrementing the top value and inserting or pushing the element 15 into the stack. Again, I am incrementing the top value and inserting this element 32 into the stack. Now, as you can see, our stack is completely full. But I have one more element that I would like to insert into the stack. But is it possible for us to do that? No, because we have already reached the maximum size of the stack. So here we have reached the overflow condition, as in our stack is completely full and there is no space left in the stack to insert new element. That is the reason why initially, as a first step, before performing push operations, we should first check if there is any empty space left in our stack. to insert new element. That is why before performing push operation, you should first check for overflow condition, just to make sure our stack is not full and there is space left in the stack for us to insert new element. So how can we get to know if our stack is full or empty? I had explained this before as well. When the top value or the top variable is pointing to the maximum index, what will be the maximum index? The maximum index will be the max size minus 1. Since we are starting from 0 and the maximum number of elements is 5, that is the reason why the max index will be maximum size minus 1. So let us write code for the same. So we need to check if top value or the top variable is equal to max size minus 1. If the condition is true, then we need to print a message saying stack is full. Here we have checked for the top value. We are checking whether the top variable contains the maximum index value. If the condition is true, we will print that the stack is full. Else, what does the else part mean? The else part means that our stack still has some empty space left in it. So when we reach the else part, we can directly push the new element into the stack. Now to push the new element into the stack, what was the steps that we were following? The first thing that we did was to increment the top value. We will increment the top value by 1. So top will be equal to top plus 1. We are incrementing the top value. In the next step, at the index pointed by our top variable, we will insert the new element. So stack of top will be equal to the new element. So we are assigning or storing the new element in the location pointed by the top variable. Finally, we have performed the stack operation. We will return back to the main method. This is the overall working of push operation. Let us understand this with some examples. Consider this as the initial status of your stack. There are 2 elements already inserted into the stack and the top variable is pointing at the index 1. Now we will enter into the push method. Initially the top value is 1 and the maximum size is 5 and the new element that we are trying to insert into the stack is 8. So the first step will be to check for the overflow condition. Currently what is the top value is 1. What is maximum size minus 1 will be equal to 4. Is 1 equal to 4? Is this condition true? No, the condition is false. That is why we won't execute the print statement. Instead, we will move into the else part. So what does the else part say? Here in the else part, we are first incrementing the top value by 1. So 1 is the initial value of this top. We are incrementing it by 1. So the new value of the top will be equal to 2. Now let us increment the top value by 1. Now the top variable is pointing at the index 2. In the next step, we are inserting or we are assigning the new element value into the index pointed by the top location. So we will insert this element into index 2. Finally, we will return out of the push method. This is how push operation works. Let us take one more example. Consider this as the initial status of your stack. Your stack is completely full. There is no empty space left in the stack to insert the element, but still we are trying to push this new element into the stack. Let us see what happens. So currently the top variable is containing value 4 and the maximum size is 5, and the new element that we are trying to insert is 8. Let's see, the first step is to check for the overflow condition. Here we are checking if the value of top, that is 4, is equal to maximum size, which is 5 minus 1. 5 minus 1 will be 4. So let's check the condition now. Is 4 equal to 4? Answer is true. The condition will be true. So since the condition is true, we will insert into the if block and print this statement. So stack is full message will be printed on the screen. Then we will directly exit out of the method. And that is how push operation works. Now let us try to understand how pop operation works with the help of top variable. Let us say this is the initial status of the stack. There are two elements that are already inserted into the stack. Now we need to perform the pop operation. So what does pop operation does? It will remove the topmost element out of the stack. So what is the topmost element in this stack? That will be 17. So we have to pop this element out of the stack. How will we do that? So the steps that we will perform will be a bit opposite of the push operation. In the push operation, we are incrementing the top value. But in pop operation, we have to decrement the top value. So the first step that you will do is decrement the top value and then return this element to be displayed as a message on the screen. That is how pop operation works. All you need to do is decrement the top value and then return this element back to the main function. What if I perform pop operation now? Our top is pointing to -1 location and the stack is completely empty. Now if I try to perform pop operation, I won't be able to retrieve any element out of the stack. That is why before performing pop operation, we have to check whether the stack is empty or not. That is, so the first step will be for us to check for underflow condition. So how to check for underflow condition? We need to check if the top value is equal to -1. We have already studied that the stack will be empty when the top value is -1. So here we are checking for the same condition, and if the top value is -1, then we will print an error message saying that stack is empty and there are no elements in the stack for us to perform pop operation. Now coming to the else part. What should we do when the stack is not empty? Simple. We need to perform pop operation. Now to perform pop operation, what is the first step that we need to do? I will just take a new variable called item and store the topmost value into that item, and then in the next step I will decrement the top value by 1. So top will be equal to top -1. Finally, I will return the popped element to display on the screen. Let us understand this with some example. Consider this as the current status of your stack. There are two elements already inserted in the stack. So to perform the pop operation, I will first take this top element and store it in a variable called item. Consider this as the current status of your stack. Now to perform pop operation, we are taking a new variable called item and we are storing the topmost element, that is 17, into this variable. So the item variable will be holding a value of 17. Next, we need to decrement the top value by 1. So currently, top variable will be containing the value 0, and then finally we will return this item to the main method. Let us see how pop operation works with few examples. Consider this as the current status of your stack. There are 3 elements already inserted in the stack and the top variable is currently pointing to index 2. Now, to perform pop operation, the first step will be to check for the underflow condition. We need to check if the top value is -1. Is the top value -1? No, the statement is false. That is why we will enter the else block. Here in the else block, the first step that we need to do is store the topmost element of the stack into the variable called item. So the item variable will contain the value of the topmost element in the stack, that is 32. And in the next step, we will decrement the top value by 1. Finally, we will return this item to the main method. Let's perform the pop operation one more time. Now the top variable is pointing to index 1. So in the first step, we need to check if the top value is equal to -1. It is not equal to -1. So instead of printing the statement, we will enter the else block. Here in the else block, the first step that we need to do is store the topmost element in the stack into the variable called item, decrement the top value by 1, and finally return this item to the main method. Now, you might have a question that we are not exactly deleting all these values from the stack. We are only decrementing the top value. The values are still present in the stack. How can you call this a pop operation? The thing that you need to understand is that whether you are using a stack or not using a stack, some or the other garbage value will always be present in all these memory locations. As soon as you decrement the top value, the previous values will have no meaning to your program. Your top might be pointing to this location as well. Here in this diagram, you might think that these two locations are empty, but no, that is not the case. Some or the other garbage value will always be present in the memory locations. But those values have no meaning to your program. And it is as good as these locations are empty, completely empty. So currently our top was pointing to this location. So all these rest memory blocks, irrespective of whether they have any value in it or not, it will have no meaning to your program. So it will be as good as those elements are deleted. Now, let me try to push this element into the stack. So the first step will be for me to increment the top value and then store this value into that location. What happens is that when I do this action, the new element will override the old element's value. So this value will be removed and the new value will be stored in the memory block. Again, if I have to push a new element into the stack, all I need to do is increment the top value and then override it with the new element's value. When I override it, the old value will be removed and only the new value will exist in this memory block. And that is how the pop operation works. I hope you have understood how both push and pop operations work.